Alrighty, today we are focusing on graphing quadratics, parabolas, and so we are going to look at our equation when we're given it in 3 different ways, and then how to find at least 5 points, because that is what I'm going to require on a test and quiz, and that is what Delta Math requires on your homework. So 5 points. So let's start. We've got standard form, vertex form, and factored form. Those are the 3 forms that we're going to see. And the 5 points we want to find is first the vertex. So if you've got standard form, you have to use vertex formula. When you've got vertex form, that's a little more straightforward. And then factored form we'll talk about when we get there. Once you have your vertex, you can draw in your axis of symmetry. Then you can find your y-intercept. Find the symmetric point using that axis of symmetry. And remember, your y-intercept is when x is equal to 0. Then we're going to find our our x-intercepts. This is when y equals 0. And once you have 5 points, we are going to connect them with a curve as best we can. You know, we're not perfect. We're not machines. But you will find that sometimes these points either are too large to be on our little 10 by 10 graph, or they're just not whole numbers. They're not pretty numbers. So if that's the case, I'm going to put or. If any of these points are not able to be plotted on your graph, you can make a table. And by make a table, I mean find an input and output pair and use your axis of symmetry to find a symmetric point. So let's jump into example A here. I have standard form, which means that to find my vertex, I'm going to have to use my vertex formula. So for this one, that is going to be -8 divided by 2 times 2. And -8 divided by 4 does give me -2. So that is, excuse me, the x-coordinate for my vertex. To find the y-coordinate, I'm going to plug in -2 for x into my function. Order of operations says I have to square first. Then I can multiply. And 8 minus 16 plus 7 is going to give me -1. So my vertex is at -2, -1. So there is my first point. Now I'm going to draw in my axis of symmetry, and that's just the vertical line that goes through your vertex. So here that's going to be at the line x equals -2. And it's not perfectly straight. I did my best. So there's my first point. Now I want to try to find my y-intercept. Again, this is when x is equal to 0. So there's my vertex. Now I want to try to find my y-intercept. So when x is equal to 0, I'm just going to plug in 0 into my function for x. And that is going to give me 7. So I've got the point 0, 7 on my graph. And now I'm going to use my axis of symmetry to find the symmetric point. So what that says is, however far away this point is on the right, I have a point the same distance away on the left, a symmetric point. So this is 2 away on the right, so I'm going to go 2 to the left to find my symmetric point. Now I have 3 points and I want to find a 4th. Well, if I go to finding my x-intercept and I set my equation equal to 0, this is not going to factor. I don't have any numbers that multiply to 14 and add to 8. So it can't factor. I could use the quadratic formula, completing the square, any of those other methods to solve this. However, I'm not going to get whole numbers if I do that. So what I'm going to do instead is just find an xy pair. I'm going to use a table essentially. So I'm going to pick an x value. Let's go with -1. You could use a different one if you want. But I'm going to say we're going to do a table, and we're going to say when x is equal to -1. So if x is -1, again, I'm going to put that into my function. -1 squared is just +1, so that's going to be 2 minus 8 plus 7. And that gives me 1. So I've got another point at -1, 1. And then to find my 5th and final point, I'm just going to use that axis of symmetry. This one is 1 away on the right, so I'm going to go 1 to the left to find my 5th point. And now, just the best that I can, I'm going to connect those dots and draw my parabola. Okay. On to example B. This one is in factored form, which is very good for finding our intercepts. So this tells me that I'm going to have intercepts at the opposite of the value in here. So at -3 and -1. So there I have 2 points already from my x-intercepts. But now I want to go ahead and find my vertex. And in order to do that, I need to rewrite this in a different format. I am going to rewrite this in standard form, first by foiling the x plus 3 times x plus 1. So that is going to give me x squared plus 4x plus 3. Then I can distribute the 2, and I get 2x squared plus 8x plus 6. Now that I have it in standard form, you could either complete the square to put this in vertex form or just use your vertex formula. So again, my x coordinate for my vertex is going to be at -2. To find my y coordinate, I'm going to plug it back in. -2 squared is 4. 4 times 2 is 8. 8 minus 16 plus 6. This time gives me -2. So -2, -2 is going to be the coordinates for my vertex. So I can go ahead and now draw my axis of symmetry. I'm going to try to get it straighter than I had on the previous one. So I have 3 points now. I need to get 2 more, but I only have to do math really one more time in order to do that, because I can use my axis of symmetry to find a symmetric point. And so what I'm going to do now is go ahead and try to find my y-intercept. Remember, this is when x is equal to 0. So I'm going to plug in 0 for x, and that will give me 2 times 3 times 1, which is 6. So at 0, 6, I have a y-intercept, and now that is 2 away on the right. So if I go 2 to the left, there is my symmetric point, and now I can connect my 5 dots. And again, it's not perfect. Desmos would do a much better job, but there is my parabola. Okay, last one. We have vertex form now. So the first thing I can do is find my vertex. That is going to be at -6, -3. Oops, I went over too far. Let me fix that. That's better. -6, -3. There's my vertex. Now I can do my axis of symmetry. Okay, now let's try to find my y-intercept. Again, that is when x is equal to 0. So 3 times 0 plus 6 squared minus 3. Well, 6 squared is going to give me 36. 36 times 3 minus 3, that gives me 105. That is way off the graph, so that one is not going to work. Let's move on to our x-intercepts instead. I'm going to set this equal to 0. And this looks like I can use my square root method to solve. I'm going to add 3. And then I can divide both sides by 3. Now I have my square by itself, so I can square root both sides. And x plus 6 is going to be equal to plus or minus 1. So x is -6 plus or minus 1. So -6 plus 1 will give me -5. -6 minus 1 will give me -7. So there are my 2 x-intercepts. Now, to get my last 2 points, I'm going to need to do a table again. So I need to think of an x value. I'm going to go with -4. So if x is -4, I'm going to plug that into my function. -4 plus 6 is 2. 2 squared is 4. So 12 minus 3 gives me 9. So I've got a point at -4, 9, which is here. And this is 2 away from my axis of symmetry, so I'm going to go 2 away on the other direction to get my 5th and final point. And now I can connect my dots. And there we go. All right, let's talk about writing the equations. So we are going to write these equations in vertex and standard form. So if you need to write this at the top of your page, vertex form is a times x minus h squared plus k, and standard form is ax squared plus bx plus c. So let's start with, I'm given the vertex and a point. Now the vertex tells me what h and k are. So I'm going to focus on my vertex form first. Now if I plug in those h and k values, that would be a times x. If I have minus negative 3, that becomes plus 3 and 3. So the only thing I don't know is a. How am I going to find a? Well, I have this other point here, which is an xy pair. So I can substitute that x and y in this equation and use that to solve for a. Well, negative 2 plus 3 is 1. 1 squared is 1. So a plus 3 equals 1, which means a is negative 2. So the vertex form for my equation is going to be negative 2, x plus 3 squared plus 3. To put that into standard form, you just need to expand it out. So start first by foiling, then distribute your negative 2, and then lastly just combine those like terms. So my standard form is negative 2x squared minus 12x minus 15. Okay, on the next one, again, I'm given the vertex in a, which means I can go ahead and immediately write this in vertex form. That's going to be negative x plus 3 squared plus 4. To put that in standard form, again, expand it out. So I'm going to start first by foiling, then distribute my minus, and then lastly combine like terms. So for my standard form, I'm going to have negative x squared minus 6x minus 5. Okay, now I'm given a graph. So here I can see my vertex is at 5, 5, so that gives me h and k. So to put this in vertex form again, I'm just going to need to solve for a, which means I need to find an xy pair. Now I know this is a little difficult to see, but I'll tell you, you can use any of these points. This point here is 7, 1. This point here is 3, 1. Down here you've got 2, negative 4, and 8, negative 4. You can use any of those. I'm going to go ahead and just use 3, 1 for now. So 1 is equal to a times 3 minus 5 squared plus 5. Again, order of operations, 3 minus 5 is 2. 2 squared is 4. So that's going to be 4a. Subtract the 5. And this time I get that a is negative 1. So the vertex form for my equation is negative x minus 5 squared plus 5. To get that into standard form, just break it on out like we've been doing. Distribute your negative. And so the standard form for this one is negative x squared plus 10x minus